Humbert, and we are going to be doing Unit 3, Notes 3. So today we're going to be talking about dividing monomials. So the previous note sheet we talked about multiplying monomials. Now we're going to talk about dividing them. So let's take a look at those couple of rules of exponents that we missed. So we talked about multiplying like bases yesterday. Today we're going to start by talking about dividing like bases. So when you divide like bases, you need to subtract the exponents. So just like yesterday when we multiplied, and then we multiplied monomials, we added, today when we divide, we're going to subtract. So a to the 6th divided by a to the 3rd. So we're going to subtract those exponents. We're going to take 6 minus 3, and that's going to give us 3. So all I did was subtract those exponents. So let's go ahead and let's take a look at that next one, the negative exponent. Whenever you see a negative exponent, you need to flip where it's located. So if it's on the bottom of the fraction, it needs to come to the top. If it's on the top of the fraction, it needs to come to the bottom. Or if it's just a number, that's considered on top of the fraction, so it would need to flip to the bottom. So this a to the negative first needs to flip to the bottom. This b to the negative fourth needs to flip to the top. So then on top we're going to have b to the 4th, and then on the bottom we're going to have a to the 1. So all we need to do was flip where it was located. So let's go ahead and take a look at putting this into practice. So here's the biggest thing. There's that little reminder on the bottom. Remember with negative exponents that you're just going to flip the location of only the thing with the negative variable. So if there's a whole bunch of stuff on top, you're only going to flip the thing with the negative exponent, not the whole thing. That's really important to remember as we move forward. So let's take a look at this first one. So I have 4ab divided by a. Well, we know that in mathematics, 2 over 2 is equal to 1. 3 over 3 is equal to 1. Likewise, a over a is equal to 1. So a over a is actually just going to cancel out. Okay, and then when it cancels out, we're just left with 4b. Okay, so when it cancels out, we're just left with 4b. There we go. Okay, so let's take a look at number 2. So for number 2, I see that a has a negative 2 for its exponent. So I need to flip where it's located. However, the 4 does not have a negative exponent. So the 4 is going to stay on the top. Remember, this is the same as over 1. So that 4 is going to stay on the top, and we're going to take that a to the negative 2, and we're going to flip it on down to the bottom. So then I get 4 over a squared. So all we're doing right now are applying those rules of exponents. So let's take a look at this one. 6a divided by b to the negative 2. So I notice that b has a negative exponent on the bottom of the fraction. So that means I need to flip it to the top in order to make it positive. So 6a is going to stay exactly where it is, and I'm going to flip that b squared to the top. So I have 6ab squared. Taking a look at number 4, I have a whole bunch of negative exponents. So this b to the negative 3 part needs to flip to the bottom. This a to the negative 2 needs to flip to the top. So the 4 is going to stay exactly where it is. It's only the b that has the negative exponent, not the 4. So that a to the negative 2, that's going to flip to the top, and it's going to become a squared. That b to the negative 3 is going to flip to the bottom, and it's going to become b to the 3rd. Okay, so similarly to our other note sheet, we talked about properties of simplified monomials. Because we've added a few new rules of exponents, we have a couple more things we need to check out for that. So just like with multiplying monomials, we need to make sure that each base appears only once. So each letter only appears once. There are no powers of powers. We've already talked about that. We don't want to have a squared to the 3rd power. That's not fully simplified. All fractions are reduced. And the new one that we're adding is that there's no negative exponents. If you leave a negative exponent in your answer, it is not fully simplified. Okay, so let's take a look at putting this into practice. What does fully simplified expressions? How do we do that? So let's go ahead and let's take a look at this first one. So what I like to do when there's multiple letters is I like to look at it piece by piece. Remember, if there's no exponent on the letter, I like to put a little 1 to remind myself that there's an exponent there. So let's just look at the a's first. So I have a to the 5th divided by a to the 1st. So I need to subtract those exponents. I need to take 5 minus 1, and that's going to give me a to the 4th when I subtract those out. And then next, notice I'm subtracting top to bottom. On the next part, I have b to the 8th divided by b to the 3rd. So I'm going to take 8 minus 3, and that's going to give me b to the 5th. Okay, so I want you guys to go ahead and try number 6 all on your own. All right, so let's take a look at number 7. So for number 7, we have to start by distributing stuff in a little bit to start off with. So remember, when we're multiplying and we're taking powers of powers, that the coefficients also have numbers on them that need to have that exponent distributed to. So 2 to the 1st power, so 1 times 4 is going to give us 2 to the 4th. For our p, that's to the 2nd power, so 2 times 4 is 8, divided by 3, and that's to the 1st power. 3 times 2, or times 4, sorry, is going to give us 4. 3 to the 1st, so 1 times 4 is 4. So let's go ahead and simplify that out. 2 to the 4th is 16, and then we have p to the 8th, and 3 to the 4th is 81. Now that fraction cannot be reduced anymore, so that is fully simplified. All right, so I want you guys to go ahead and try number 8 on your own. It's done in a very similar fashion. All right, let's take a look at number 9 and number 10. So here I have x squared divided by x squared. So I'm going to go ahead and I'm going to subtract those exponents. So 2 minus 2 is going to give me 0. So think back to what we talked about yesterday. Anything to the 0 power is going to be equal to 1. So this one is going to be equal to 1. Let's take a look at number 10. So for number 10, what I like to do is I like to make sure the numerator and the denominator are fully simplified before I move on. So I have x to the 1st times x to the 3rd. So I'm going to add those exponents, and that gives me x to the 4th. Then we're going to divide that by x to the 4th. So now I want to go ahead and subtract those exponents because I'm dividing them. Well, 4 divided by 4 minus 4 is going to give me 0. And again, anything to the 0 power is going to be equal to 1. Okay, next, let's take a look at number 11. So for number 11, we have a lot of negative exponents. Recall that whenever you have a negative exponent, you need to flip where it's located. So let's do that. So I'm going to take this b to the negative 3, and I'm going to flip it downward. I'm going to take this d to the negative 5, and I'm going to flip it upward. Okay, so I'm going to keep that c squared exactly where it is because it doesn't have a negative exponent. Okay, then I'm going to keep that b, that's going to move down to the bottom because it was negative on top, so it'll be positive on that bottom. Now the d is negative on the bottom, so I'm going to flip it to the top, and that's going to make it positive. So then up here I'm going to have d to the 5th. So this right here is fully simplified form. None of those letters can be combined any further. Okay, so let's start taking a look at simplifying number 12. So for me, for starters, I like to do two things. I like to reduce the fraction, and I like to flip anything negative, and I like to just get that taken care of right off the bat. So first I notice I have the fraction negative 3 over 21. Well, I know that that can be reduced to negative 1/7. Both of those are divisible by 3, so I can reduce that fraction to a negative 1/7. So then I see that this a is negative on top. So I'm going to go ahead and I'm going to flip that a to the bottom. So I've got that part taken care of. So I'm just going to go about it piece by piece by piece. That b to the 7th is positive on top, so I'm going to keep it on top. A squared is positive on the bottom, so I'm going to keep it on the bottom. B to the 7th is positive on the bottom, so I'm going to keep it on the bottom. Last but not least, c to the negative 5 is negative on the bottom, so I'm going to flip it to the top, so it'll be positive. So now I need to go about simplifying a couple of things, okay? So, negative 1/7 I can keep. Okay, here on the bottom I have a to the 4th times a squared. So I can add those exponents. 4 plus 2 is going to give me 6. And this should be b to the 7th. So then I notice that I'm going to end up having b to the 7th divided by b to the 7th. Well, that's going to be 7 minus 7, so I'm going to have b to the 0. So my b's are going to cancel out. And left on top is that c to the 5th power. So then I have negative c to the 5th power divided by 7a to the 6th power. Let's take a look at number 13. So again, let's just simplify it piece by piece. So I'm going to try and reduce this fraction to start off with. So negative 3 divided by negative 12. Well, both of those, first of all, are going to become positive when you divide a negative by a negative. And both are divisible by 3. So that's going to end up being 1 over 4. Now let's go simplify. Q to the negative 2 is negative on top. So I'm going to flip it to the bottom to make it positive. So I got that taken care of. R is positive on top. R to the first I'm going to keep up there. S to the fourth is positive on top, so I'm going to keep S to the fourth up there. So now I've taken care of my numerator and my negative 12. Q to the first is positive on the bottom, so I'm going to keep it on the bottom. R to the negative 3 is negative on the bottom, so I'm going to flip it up top. S to the negative 5 is negative on the bottom, so I'm going to flip that up top. So now I want to go ahead and I want to simplify out what I have. Okay, so I have 1 and I have r to the first times r to the third. We'll add 1 plus 3 and that's going to give us r to the fourth. S to the fourth plus s to the, or times s to the fifth, we're going to add those exponents, that's going to give us s to the ninth. Divided by 4, and then q squared times q to the first, add those exponents and you get q to the third. Okay, and if you wanted to, you don't have to write that 1. I just put it there because we reduced our fraction, but if you don't want to write that 1 there, you don't have to. So that is your fully simplified monomial. So I want you guys to go ahead and try number 14 on your own. So let's take a look at number 15. It says write the ratio of the area of a circle in its simplest form. So we know that it's t. So to find the area of a circle, it's going to be pi r squared. So we want to figure out it in the simplest form. Okay, so if the circle is t, that means the length of the square going all the way across this side is going to be 2t. And remember, for a square, it's length times width. And then we have the other side of the square that's also going to be 2t. So we want to take the area of a circle divided by the area of the square. So the area of a circle is pi and then r squared. Well, r represents the radius, and the radius of my circle is t. So that's pi t squared. Then on the bottom, we're going to take 2t times 2t. That's our length times width. And 2t is just fun to say. Okay, so let's simplify that out. So we get pi t squared divided by 4t squared. Well, my t squareds are going to cancel. And then I'm left with pi divided by 4. So no matter how big your circle is, how big your square is, if you take a square and you fit a circle inside of it, the ratio of the circle to the square is going to be pi over 4. So that concludes your note video of today. Go ahead and make sure you take your Schoology quiz. Thanks for listening.